Okay, I think we are all ready to begin today's session. So, without further ado, let's begin. And here we go. All right, so I guess that is it. So, hello everybody, and welcome to our first ever Paper 6 review for Homeschool.Asia. So, for today's session, we will be solving the entire paper for IGCSE Physics, subject code 0625, Winter 2025, Paper 6, Set 1. So, for our session today, right, we are going to go through the entire question paper and explaining how to solve each question in detail. And I hope everyone here finds this useful. So what we'll be going through today is paper 6. Paper 6 is the alternative to practical for IGCSE Physics and for the sciences. So even though you are not required to conduct the experiments, students will be tested on the skills that are required for practicals and use it in the theoretical settings. And as you know, these skills will be tested. So these are the skills that will be tested. Firstly, you need to learn how to safely use the techniques, apparatus, and the materials given in the questions. So what does I mean by that? You need to identify, draw, label, and explain how these apparatus and materials are being used. You need to select the appropriate apparatus and materials for the task, and you justify the choice made. You need to describe and explain hazards and safety precautions. You'll also need to describe and explain the techniques used to ensure a good accuracy of data. One of the next tasks, what's it called again? One of the skills needed to be planned as well is also you need to learn how to plan experiments and investigations. So firstly, you need to identify independent and dependent variables and how they are controlled. You need to describe experimental procedures. You need to identify risks, such as safety precautions, how to record results, and how to process the results to form a conclusion or evaluate a prediction, and to make predictions from our expected results. Next skill, you need to make and record observations, measurements, and estimates. So what constitute that? You need to know how to take readings from apparatus and diagrams of apparatus. You need to take readings with appropriate precision and to the nearest half scale. You need to correct for zero errors. You need to make observations, measurements, estimates in agreement with expected results or values. You need to take sufficient observations or measurements to be reliable. So essentially, how many data points you need in your table and graph. You need to repeat observations or measurements when needed. For example, you need to take multiple readings to make an average reading for better you need to do that for a better accuracy of your results. You need to also record these qualitative observations for tests systematically in a suitable table and using suitable degree of precision and using the correct units. All right, this is quite a mouthful. Next, one of the next skills you need is you need to learn how to interpret and evaluate experimental observation and data. And you need to learn how to process data, including those for use in further calculations for graph plotting, and you need to use a calculator when required. Next, you need to present the data graphically and use a best fit line when appropriate. You need to use interpolation and extrapolation to graphically determine the gradient or intercept. In the form conclusions justified by the reference to observations and data with good explanations. You also need to evaluate the quality of observational data, identifying any anomalous results, and taking appropriate action. So either you want to reject that result or you want to bring it in to our explanation. And of course, you need to comment on and explain where the results are equal to within the limits of experimental accuracy, right? And last but not least, the last skill you need is you need to evaluate all these evaluate all the methods you use and suggest possible improvements. So for example, you need to evaluate experimental arrangements, methods, techniques, controls of variables, so on and so forth. And next, you need to identify the sources of error, including measurement, random, and systematic errors. You also need to identify causes of uncertainty in data or in the conclusion, and you need to suggest possible improvements on the apparatus, experimental arrangements, methods, or techniques that are usable, right? So quite a mouthful, right? Let's in the meantime, once that is done, right? This is gonna be quite a simple paper. There's only 4 questions. So these 4 questions, right, will be very straightforward. The first question is very simple, usually makes you do some measurements, makes you do some data processing. The second and third question will maybe make you draw diagrams, will make you draw a graph, can be a little bit more complicated. And the fourth question requires you to fully plan the experiment and write out what are the possible results from this experiment and make your own conclusion after that. So yeah, the fourth question requires you to write down quite a lot. Well, without further ado, I think we have completed what we need to talk about and what we need to look out for. Now let's move on with question 1 of paper 6-1. All right, give me a second. Okay. Fantastic, that is fixed. And let's move on to question 1. Oh, we have an issue. Give me a second. Okay. Oh, there's some issues with the stuff, so give me a moment. All right, I think for today's session, you don't have to see my face. Let's do the question. All right. So let's start with question 1. All right, so question 1. In this scenario, a student investigates the balancing of a meter ruler. And as seen over here, figure 1.1 shows the whole apparatus. So as you can see over here, this is the ruler, right? And this is the 2 loads being added over here. And the whole ruler is balanced by a pivot at the 50 cm mark. Okay, so let's take a look here in part 1a. So over here, the student placed a meter ruler on the pivot at the 50 cm mark. And she places an object Q over here with its center on the meter ruler on the 90 cm mark. Okay, yeah. So next, we need to determine the distance y from the 50 cm mark to the center of object Q. All right. So let me finish this first. Then let me try to fix some of the gremlins of our program. All right. So simply put, we need to find distance y between the 50 cm mark and object Q, which is on the 90 cm mark. So y is just simply 90 minus 50 cm, and you get 40.0 cm. Do remember, actually, this is 90.0 and 50.0 because we have 1 decimal point here. All right, so the distance of y is 40.0 cm. Okay. All right. Very good. All right, so now give me a short moment while I fix some back-end gremlins on our questions. There we go. That's a bit better. I think everybody can see the screen now. All right, fantastic. Okay. Yep, there we go. I am speaking a little bit softer, so let me just increase the mic volume as well. Yep. And okay. Can everybody hear me? See me now? All right. Great. Let's continue. All right. Sorry for the slight technical gremlins. Let's continue with our question solving. All right. Okay. As you've seen just now, we just solved for question 1a, where y, which is the distance between the 50 cm mark, and q, which is the 90 cm mark, to be 40.0 cm. Okay, 40.0 cm. So now let's go to part B of this question. So over here, the student places the 2 Newton load, 2.0 Newton load on the meter ruler, which is over here, this one. All right, and she adjusts the position of the load so that the meter ruler is as near as possible to being balanced. And she measures the distance x from the center to the load to the 50 cm mark. Right, the distance x from the center of the load, which is this guy, to the center of the load to the 50 cm mark, which is here. And distance of x currently right now is 21.5 centimeters. So, firstly, we need to calculate the weight of object Q using the equation W equals to x over y times 2.0 Newton. We need to find the weight of object Q, right? So, let's find it right now. W is equals to x over y times 2.0 newtons. So, as you've seen before, x is 21.5, right? And y is 40.0. Multiplied by 2.0 newtons, which gets you this. Okay, 1.075 newtons. Of course, this is not our final answer. We must put this into its proper significant figures, right? As seen over here, the number of newtons, the number of significant figures on the newtons over here is 2 significant figures. So let's also correct this to 2 significant figures, which is 1.1 newtons, correct to 2 significant figures. All right, so we have our answer as 1.1. All right, thank you for your answer. You had to ask me to scroll up a little bit. Let me also zoom out just a little bit so it makes the viewing a little bit easier for everyone. Is this okay? Yeah. All right, now let's move on. Okay. All right. So our answer over here for question 1B1 is 1.1 newtons. All right, please remember to write it in the appropriate area and with the correct number of significant figures. All good? Okay, that's 2 marks gotten. So sorry to forget about this just now. I'd like to also let you guys know where are the marks given. Okay, and so for 1 part A, right? For this question, 1 mark is given if you write down 40.0, and 1 mark is given if your answer is correct to the nearest 0.1 centimeters. Okay, this is your 2 marks over here. As for B part 1, you will get, there is also another 2 mark part, right? So 1 mark is given, right, if you write W, right, over here is equals to 1.1 newtons. The second mark is given if you give it in the correct significant figures. Of course, over here, Cambridge allows 2 significant figures or 3 significant figures. Okay, so here we go, 2 marks gotten. Solid. All right, now let's move on to the next part. All right, so the student repeats the procedure using a 3.0 Newton load, and she does not change the position of object Q, which means she will now take the load over here, which is now 3 newtons, and balance it over here. And she measures the distance between the 50 cm mark and this new load. And this new distance is now 14.8 cm. All right. Now, using this information, let's once again calculate the weight of Q using this equation. All right. So let's use W equals to X over Y times 3.0. W equals to X over Y multiplied by 3.0. All right. As we have seen just now, X is now 14.8. Okay. And Y just now is 40.0 multiplied by 3.0 newtons, right? And that, doing the calculations on your calculator, you should also get a very similar result, which is 1.11 newtons. And once again, let's round this down to two significant figures, which gets you 1.1 newtons, correct, to two significant figures, right? So over here, let's write down 1.1 once again. So this is a 1 mark question. So if 1 mark is given here, if you use the same number of significant figures here as part 1 over here, since it's 2 and 2, you get your 1 mark. Okay? Now, with that said and done, let's move on to part C. So, part C wants you to state and explain whether your two values of W are within the limits of experimental accuracy. And you are to refer to the values of W within your answer. So as you can see over here, right, our values of W are equal. They're actually both 1.1. So what that means is also very straightforward. So both values of W are equal, and of course, that means it is within the limits of experimental accuracy. Okay, hang on a minute. What's going on? Okay. Right, testing. Is my volume still very soft? Or I have to speak a bit louder? Let me move my mic towards me a little bit. Come on. All right, I think this should be a little bit better. I have to speak closer to the mic then. All right, so let's move up over here. So let's state and explain whether our two values W are within the limits of experimental accuracy. So since our values of W are 1.1, we can say that yes, these values are within the experimental accuracy. So let me just write that down. So statement. All right. So we need to write a statement, which is the two values of W are within the limits of experimental accuracy. And we need to explain why using the two values up there. And since they are equal, we just have to write that down. All right. This is because W equals to 1.1 newtons, right? Right? Because W is equals to 1.1 newtons as calculated. From both experiments. All right. So, of course, this is a 2 mark question. The first mark is to state correctly if W is within the limits of accuracy, and this is the first mark. And second mark is a correct explanation of why this is so. Doing so will get you your full 2 marks of the question. Okay, right? So with that done, let's move on to part D. So part D wants you to explain how you are how you ensure the center of object Q is directly over the 90 cm mark of the meter ruler, and you may draw a diagram. Okay, so this is a 1 mark question that wants you to explain how you ensure object Q is directly over the 90 cm. The center of Q is over 90 cm mark of the ruler, and the diagram can be used to clarify. All right. So how is that done? Pretty simple actually. Let me draw to show you how this is. This is a very good way to do it. So, for example, this is object Q, right? Pardon my cruddy drawings. Okay, and this is the 90 cm mark. Okay. So, what we need to do, right, is to make sure for both sides to be for the middle point of object Q to be directly over this thing, right? We need to ensure this distance and this distance, right? Let's call it x cm. X and x, these two has to be equal to ensure Q is on the center of the center of Q is directly over 90 cm. So this is our diagram, okay? And we should write over here, right? It's quite a lot to explain, but let's keep it short and simple. Okay, the edges of object Q should be symmetrical. Okay, on either side. Of the 90 cm mark. Okay, right? This is pretty straightforward, yeah? So as long as, right, in this question, as long as you show, right, that both sides of the object Q is directly over the center, and both sides are equal or are symmetrical, we are good. Okay, and this gets you your full 1 mark. Oops, silly me. Delete this. Yeah. Right, so you get your full 1 mark. All right, great. So far so good. This is very simple. Okay, and wait a second. Okay, now let's go to part E. Can everybody see this? Okay, right. So part E is stated that, right, it is difficult to find the position of the load to obtain the exact balance of the meter ruler. So you have to explain how you try to overcome this difficulty. So as you see just now from our experiment, right, the meter rule, right, when you balance an item over here, it actually goes up and down very, very much, and it's very difficult to balance this meter ruler. So we are to try to use a different method. We try to use a method to try to overcome this difficulty in order to better balance this ruler. Okay? So there are a few ways to do this actually. So the first method, of course, is always to do an average of 3 readings or more. That is the average method. Or you can move the block over here forwards and backwards very, very small lengths in order to determine properly. But I would still feel that the average is still better. So let's write down the answer over here. All right, so okay, let's write it down. One method of determining, okay, the position of the load, right? More accurately, right, is to take an average. Okay, whoops, my bad. To take an average reading out of 3 or more readings. Okay, right? This is just one method. There should be more, but as long as you have one of the more, acceptable answers, you get your full 1 mark. All right. With that done, let's move on to part F. All right. So over here, as you can see, part F shows the meter rule balance on the pivot with no loads, right? The pivot is right over here. And the balance point shows the position of the center of mass of the meter rule. So determine the distance d between the 50 cm mark on the meter rule and the center of mass, and you are to show your working. Oops, I'm sorry, excuse me. Right, so for this question, you will need a ruler. So even though I'm drawing on a digital board right now, a ruler is necessary even for the analog part. All right, so let's take a look here. So over here, that is where your ruler should be, and it should draw directly straight downwards. Okay. Now, as you can see over here, right, this line over here is 1, 2, 3 millimeters away from the 50 cm reading. Okay, so this is about 3 millimeters. Okay, or should I say 0.3 centimeters. Okay, so we are determines the distance d, which is 3. Okay, first we need to draw the line. Second, we need to find this. So basically 50 minus 49.567, right? So first we say pivot is, okay, oops, my bad. Okay, let me just go up a little bit. All right, so that's better. Right, so we just need to do this distance d, right, from 50 cm marking is equals to 50.0 cm minus 49, 49.5, 49.6, 49.6, and 49.7. So 49.7 over here. And that gets you 0.3 centimeters. Okay? Right? So D is 0.3 centimeters away from the 50 cm mark. And that's where the center of mass is. Okay? So this is also a 2-mark question. As long as one, you show a correct working, which is pretty much drawing a line down like this and finding out where exactly a center of mass is. And number 2, you need to do the correct number over here, which is 0.3 cm or 3.0 millimeters. That works as well. Okay, 3 millimeters, sorry, no 0 here, just 3 millimeters. All right, so either 0.3 centimeters or 3 millimeters. This is all you need to secure the full 2 marks for this part. Okay, and with that, look, we are done with question 1 of this paper. Pretty simple, yeah? Okay, I guess everyone is pretty much okay right now. So for question 1, I'd like to ask if there's any questions so far with this with this paper so far. If you have any questions, please ask the comment section on chat, okay? And my friendly tutor, Mr. Narayan sir, will take a look at them and convey them to me, and we will answer it as we go move on, okay? Without further ado, let's move on to question 2. All right, so question 2 over here, let's see. All right, so question 2, right? The student investigates the resistance of a wire, which is over here at BC, all right? And figure 2.1 is the circuit that he uses here. And as you can see over here, this circuit is connected to an ammeter over here and a voltmeter over here. And if you do remember, right, an ammeter must be connected in series, while a voltmeter has to be connected in parallel to the object you are measuring. All right, so let's move down to part A, right? As seen in ammeter, it has this reading right now, so we are to record this ammeter reading here. Okay, so this ammeter reading is very straightforward to read. You can see the markings are in the markings are marked in graduations of 0.2 amperes over here. So basically this is 0.1 over here and 0.2 here, 0.3 here, and so on and so forth. Now this needle right here is pointing over here, which is one small unit after 0.3. So each of these small markings denote 0.02 amperes. So this reading is now 0.32 amperes. Okay, pretty straightforward. All right. Okay, this is pretty straightforward, isn't it? All right, let's move on. And that gets you your full 1 mark. Okay, so next thing, let's read through this question. So the student places the sliding contact 15 centimeters from B. What does this mean? So as you can see, the sliding contact is over here. The student places it 15 centimeters from B. Okay, and this student then measures the potential difference V across the length D, which is 15 centimeters of resistance. Okay, and then he repeats the procedure using values of D equals to 40, 60, and 80. So in other words, he starts from 15 centimeters over here, then he moves on to 40, 60, and 80. All right. And he records the values of D, B, and R in table 2.1 over here. All right, so you can see 15, 40, 60, 80, and 100. Okay. Right. And the voltmeter reading he obtains when D equals to 100 is shown in figure 2.3. So once again, we are now looking at an analog voltmeter, and we are to check out, right, what is the reading on the voltmeter. We have to record on the last row of table 2.1, the voltmeter reading as shown in 2.3. All right. Okay, as you can see over here, this voltmeter the numbers are registered as volts, right, in singular volts. So 1 volt is the big reading over here. And between these two, there are 10 markings. So each small reading is 0.1 volts. Okay, so right here, the reading on the voltmeter is 2.12345, 2.5 volts right here. So, whoops. Now that is, oh my goodness. Now that is determined already, we are to record the value of the voltmeter down in table 201. So let's write it down. 2.5 volts. Okay? Pretty straightforward. And that gets you your 1 mark. All right. So you get your 1 mark if you write the correct number down in here. Okay? Very good. Now, in here in B part 2, we are to calculate the resistance of R, right, of 100 centimeters of the resistant wire using the equation R equals to V over I, right? And we are to record the value of R in the last row over here. So here we have written R is equals to V over I. And over here, let's see. Record R over here. All right, give me a second. Okay, so as you remember from the past, right? The ammeter is measuring the circuit, the current of this entire circuit, and it never changes. While the voltage over here, the voltmeter, the reading here changes as the sliding contact is moved from B to C. So we already have the reading of current, which is 0.32, and we have the reading of the voltage, which is over here 2.5 volts. So once again, let's take V, which is 2.5, divided by the reading of I, which is 0.32 over here, and doing some final calculations using the calculator, you shall get 7.81425 and so on. And of course, once again, we want to follow the number of decimal places behind. Here we need to follow the rest of these the significant figures or the decimal places according to the row over here. So this time round, let's write 2 decimal places, as this is what the table gives. All right, so we need to look at 1 over here and 4 over here. So 4 is less than 5. So you are to round this down to get 7.81 ohms. Okay, let's write that down over here. 7.81 ohms is written over here. And also, we are to complete the column headings in table 2.1 in part 3. What does it mean? The column headings are over here. What are the units for these table headings, right? So, first things first, we can see, right? First thing here is distance. Distance usually is, as we have seen before, is in centimeters, in cm. Okay. Next, we have voltage, V, in volts. Right? The potential difference is always in volts, and that's usually that's represented by V. And resistance over here, R, is denoted with the unit of ohms over here. So let's write that down as well. Ohms over here. Okay, so writing down 7.81 over here gets you 1 mark for part 2, and writing down the column headings over here with cm, volts, and ohms shall also get you your 1 mark. Okay, pretty straightforward, yeah? Okay, very good. All right, now let's move on to part C, where we are needed to draw, okay, a graph of resistance in the y-axis against the length d in the x-axis, and we are to draw the best fit line. Okay, for a lot of students, right, graphs kind of, give you guys trouble because you don't know what to do. But let's just keep it simple. Let's just keep it straightforward, okay? Cambridge won't really destroy you guys for graphs. So please don't feel so bad about it. It's actually not as hard as you think it would be, right? So first things first, let's draw the axis over here. Okay, pardon this. I'm going to show you guys a more, a better better drawn graph over here in the future. So not to worry if my drawings are not perfect. Okay, so first things first, let's draw the proper the axis over here, the x and y axis, and what are they supposed to represent? Okay, so please ignore the not so straight line. So first things first, you draw the axis. Please remember to draw an arrow up here and down here. Okay, this is the x-axis, this is the y-axis. So as stated over here in the graph, you are to plot resistance of plot a graph of resistance, which is R, and it is ohms over here in the y-axis. So let's write down R slash ohms over here against length D in cm on the y-axis. So let's write down D slash cm over here. Okay, we are to draw the best fit line, and we are to plot all the numbers up here. Okay, so first things first, let's take a look at D. Right, D has these are the values we need. We have 15, 40, 60, 80, and 100. So the range of D is from, let's say, from 15 to 100. Do take note, right, for Cambridge standards, right, if you are to draw a graph on the given grid over here, you are to fill up at least 70% of this graph, all right? Not doing so will deduct you marks, okay? So now that we know that it has the value from 15 to 100, we can draw a proper scale of this. So for example, let's say this is that we have one, 2, 3, 4, 5, maybe a sixth one here. So maybe you can take 100 divide by maybe 5 readings. We can get, 100 over here. We get 80 over here. We have 60 over here. We have 40 over here. We have 20 over here. And we have 0 over here for our x-axis. Done. All right. Now let's look at our y-axis. What's the range of values? So over here, you have 1.25, 3.44, 4.38, and so on and so forth. So the smallest value is 1.25, the largest value is 7.81. So this is almost at 8, right? 8 ohms, right? Here we can have about 1 ohm. So with this in mind, we need to take a look at how many markings we can do over here. So we have 1, 2, 3, 4 big markings, maybe a fifth one down here. So as you can see, 8 is the largest value, 1 is the smallest value. We can actually put maybe 8 over here, 8.00, right? And as we move down, we can have maybe 6.00 here, 4.00, 2.00, and 0 at the bottom here. So we have a pretty much nice x and y axis over here. So do take note, right? If you draw a good if you draw the axes that are correctly labeled and correctly placed, and give that will give you 1 mark. If you draw a suitable scale like this, right, with correctly plotted points, you get your 2nd mark. Okay, very good. Now let's move on to this. Okay, now we are to start plotting our values over here. So let's zoom in just a little bit for everybody to see clearer. All right, that's better. All right, so as you can see over here, okay, 15 is our first value, 1.25 is our y value. So we are to find, all right, so one is 15 and one is 1.25. So 15, as you can see, this is 10, right? This is 10, and then 15 is right at the middle right here. So we draw upwards, it should be around here. And then the next value we need to know is 1.25. So here is 1.00, right? This is 1.5 over here. So 1.25 is between 1.00 and 1.5, right? So it should be somewhere in the middle over here. So roughly we put it inside this x over here, right over here. Okay. Oh, thank you. Alright, sir, sorry about that. Thank you. Thanks for showing for giving me the heads up. We need to screw up a little bit. So yes, as I repeat, let's repeat again. We are to plot 15 and 1.25 on this graph. So 15 is over here, as you can see, right? So we can kind of use a ruler to draw a point up to here. And 1.25 is somewhere around here. So 1.0, right? 1.2, 1.4, 1.6, 1.8. So 1.2 is around here, is slightly above 1.2, so you can just kind of draw the x somewhere around here in this hole over here. Okay, yeah, do make sure, right, the center of the x, right, is exactly at where you want it to be. Okay, making sure this is accurate, right, will give you the mark you wanted. Okay, all right, so let's move on to our next few. Okay, give me a second. My pen is having some small issues. Fantastic. All right. All right, that's great. So this is done. Let's move on to um our next one. Our next okay, 1 second. Great. So our next point we need to plot is 40 and 3.44. So very nicely here, 40 is already been labeled for you. It's along this line. And 3.44, we can do it this way. So this is 3, this is 3.2, this is 3.4. We can draw a line up here. 3.44 should be somewhere up here. Okay, so let's just put the cross here. Next, let's move on to our next value, which is 60 and 4.38. 60 is already been nicely labeled here, so sorry about that. You have to draw this properly. Okay, and we are to find 4.38. 4 is here, 5 is here, so this is 4.2, this is 4.4. Okay, 4.4 is here. 4.38 is very near to 4.4, so we can just put the X marking somewhere around here. Okay, make sure this is around the 4.4 area. All right. Next, let's move on to 80, which is right here. 80 is here, move up, and 6.56, which is up here some more. 6.2, 6.4, 6.6. Right, 6.56 is closer to 6.6 over here. So let's just move it up to here, 80. We can just put a plot right here. And finally, we have 100 and 7.81. So 100 is this line over here, and 7.81 is somewhere down here. So this is 7, 7.2, 7.4, 7.6, 7.8. Okay, right? 7.81 is very close to 7.8. So let's just draw it right on the dot over here. Okay, now you have your 5 plots on the graph, and if your plots, right, are correct to the nearest half small square, they give you that 1 mark. Now for clarification, let's show you a diagram that I has drawn already over here. Okay, let me just zoom this out just a little bit to show you guys. All right, now can you see this? Can you see this graph over here? Yeah, as you can see, R is here, B is here. Okay, we have that nice 2 axes. Okay, and we have the values 2, 4, 6, 8. Actually, this should be 0.0. We should actually write this to the correct this should be in the correct decimal places with the values over here. All right, same thing here, 20, 40, 60, 80, 100. So we have the points over here. This is 15, 1.25, 40, 3.44, so on and so forth. Okay, all right, do take note, right? I'm writing these values because it makes the showing you guys easier. But in the exams, these plot points, right? These plot values are not required to be written down in our papers. So please don't write this down, okay? So for in the meantime, just remember these are not needed, huh? All right. Now that we have our plot points nicely drawn like this, okay, we are now going to draw the line of best fit. So what makes the line of best fit important, right, is you have to draw the line in such a way that, right, it runs nicely, right, very, very, very closely to the plot lines, and it is recommended for the number of plots that are above to be somewhat equal to the number of plots in the bottom. So in our case, right, our plot should have 5 plots in total. So roughly 2 should be above the line, 2 should be underneath the line. So let's draw our line of best fit. Okay, right here. You can roughly draw it like this. Okay. Oh, my bad. This is very, very bad, actually. Like that, you really can't. You must have an actual ruler to do this, and not just freehanding this or something like that. Okay, please don't be like me and draw with a ruler. Oh, here, you must use a ruler on the paper itself. Okay, so something like this, you have 2 plots on the bottom and 3 plots on the top. This is fine, okay? So let me show you guys how a line of best fit looks when you properly draw the line. Okay, as you can see, the line of best fit is nice and very thin. Please remember to use a very sharp pencil for this. You don't want your line of best fit to be very thick. You want to have make sure your line of best fit is thin. You make sure it is easily readable. Okay, if your line of best fit is too thick, it makes it very difficult to read, and you have errors reading the graph. Okay, yeah. So now that we have our line of best fit over here, 2 plots in the bottom and 3 plots on the top, we can call this done. Okay, and of course, when you draw a thin continuous line, the line of best fit, right, you get your last mark. So a 4-mark question for drawing the graph, the marks given to you are as follows. Okay, let me just zoom this out just a little bit more. Oops. Okay, so a 4-mark question, right? They'll give you 1 mark for correctly labeled X's over here and correctly placed. The second mark is for a suitable scale based and correctly plotted points for the scale. Okay. The third mark is for the correct plots over here, small little X's as we've seen over here. And the fourth mark is for the very, very nicely drawn and thin, okay, line of best fit. Please don't use this, okay? All right, but this is kind of what we want, okay? All right. Now, the graph is drawn, okay? Let's take a look, right, at, give me a moment. Hey. Let's take a look at part D over here. Part D wants you to determine the resistance of R75 of length D is equal to 75 cm of the resistance wire. So we are to show clearly on the graph of how you obtain the value. Right, let's draw the graph that we have already nicely done just now. Okay? Over here. Over here, all right? So this is the graph that we already drawn nicely. Okay? Now we are to find what happens when D is equals to 75. So let's zoom in once again to find 75. All right, so 75, as you can see, is somewhere around here. 60 is here, right? 70 is here. Okay, this is 70. And then we have, okay, 72, 74, 76, 78. So 75 is right between here on this tiny little square. So let's draw 75, right? 75 over here, we want to draw a straight vertical line upwards. All right. Oh my goodness, that's really, really bad. Delete. Okay, let's try again. 75 is here. Ruler over here. And up you go. 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 Okay. Pardon this wrong line over here. This really badly drawn line over here. All right. This is just me and some computer issues. So 75 will get you somewhere around here. Okay. And now let's draw another line. Actually, you know, this should be dotted instead of one continuous line. So let me just do that properly. Okay. So right here, let's draw it. 75 right here. So dotted. We need to draw the dotted line, right, like this. Okay. Okay, pardon the really bad drawing. And now you see it hits here. We are to draw the line from over here to the y-axis, which is over here. All right. So we have the values right here. So when the graph is when the value of d is 75, the value of r over here is 6.00. Okay, and of course, when you draw this properly, you get this, something like this. Okay, take the green line as the dotted line you want to see. All right. Okay, so R75 should be equals to 6.00. Okay, or should I put it in the two significant figures? 6.0 ohms. Okay. All right. So this is a 3-mark question. How do you get the full 3 marks, right? 1 mark is for the method we have described just now. If you draw one line up from 75, right, up to here, and draw a line down to 6 here, this is the method used to find the value of R75. Okay. Next, the second mark you get is if you read the value of R75 is correctly read to half a small square. So as long as your value is somewhere, half a small square around 6, you are good. And last but not least, 1 mark is awarded if your value of R75 is between 5.6 to 6.4 according to our marking scheme. So this is how do you get your full 3 marks. All right, and that wraps up question 2. Done. All right, so far any questions from chat? Any questions from chat you guys want to ask? Please let me know. Yes, very good. I'm seeing you guys are following very well. Well done, chat. Well done, Startup. Hello, everybody, and good to see that you guys are following our questions so far. Okay, so for one more thing to take note for this sort of question is, right, for paper 6 is I would not recommend doing this digitally. Instead, please print out your questions. Please print out everything and do everything on pen and paper. This is very important. A lot of these skills are doable only on pen and paper. Okay. Right. With that done, let's move on to our next question, which is question 3. Right. All right. So over here, we have a question that requires you to do a lot of drawing. All right. So give me a second. My pen is having a little bit of issues. Yeah, that should be fine. All right. So let's take a look at question 3. All right. So for this question, a student investigates the refraction of light. All right. Remember refraction, not reflection, in the material of a transparent block ABCD over here. All right. And figure 3.1 shows the ray trace sheet, and the student places a transparent block on the sheet and labels the block ABCD. So this is our transparent block. Okay. Right. So over here on figure 3.1, we draw a normal NL to the side AB of the transparent block at a distance of 2.0 cm from A. And we are to continue this normal that it passes through the side CD of the block. And we are to label the point S where NL crosses AB. So when NL crosses AB, this normal, right, you should label it S. All right. So this is a pure drawing question, and this is the reason why I would suggest you guys to go and print this worksheet, because trying to draw this digitally will be really difficult. All right, and please print this 100%, 100% on the paper. So whatever you see on the paper is whatever you get. Whatever you see on the PDF file is what you see on the paper. All right. I've done this digitally, and I have actually measured the distance, the length on my computer screen using a ruler. So I did this so you don't have to. Okay. Right. So first things first, you need to measure 2 cm, all right, from A. Okay. And you need to draw a normal and L. So what exactly is this normal, right? A normal is simply a line that is perpendicular to a surface like this, right? A boundary surface. It is a vertically perpendicular line. So first, we need to measure 2 cm like this from here to somewhere around here. All right. Has to be 2.0 cm. Okay, this is about 2 cm or so from A to here. Okay, and let me just find the diagram that I have already done beforehand. Okay, so let's say 2 cm as you measured with your pen and your whichever with your ruler, you measured it 2 cm to be about here, this point here. Okay, all right. So now we are to draw a normal. So what you do over here is simply you put your protractor over, the center of protractor should be around here, and you can put it 90 degrees here. So all you need to do is do that and draw a nice straight line. Okay, draw a nice straight line like this using your protractor. Okay, ooh, my goodness, that is bad. Okay, please draw a nice straight line like this. This is definitely not straight. This is not 90 degrees. My bad. Give me a second. This will take a while to get used to. Yeah, that's more like it. Ah dear. Okay. Give me a second. I am still not used to this. All right, let's go. One nice straight line like this. And please remember to draw the right angle mark here. Okay. This is your normal and L. All right. So normal line is NL is here. Okay. It should look like this. And where, right, NL crosses AB, we have to call this S. So S should be around here. Okay. All right. So let's also label this NL. N and L. Like this. Okay. So if you were to draw this properly, right, as I've done before, it should look something like this. L is at the bottom, N is on the top here. And please remember to draw this line, this right angle indicator over here. Okay. All right. So so how are you going to get your full, how are you going to get your marks for this? This is a 2-mark question. Okay. So to get your full 2 marks, right, you are to make sure, right, R at the point, okay, RS, if this line over here is perpendicular to AB. Am I supposed to draw RS instead? Give me a second, huh? Okay, very good. All right, so you have to make sure this normal is actually 90 degrees. So the invigilator will actually put their protractor over here to measure if it's actually 90 degrees. Okay, and 1 mark is given if this intersection is exactly 2 centimeters. All right, so this has to be 2 cm. This is from here to here. This is 2 cm. Okay, great. And with that, you're done with part A. All right. Now let's move on to part B. We have to draw a line RS at an angle of 30 degrees to the normal above AB and to the left of the normal. Okay. And the student places 2 pins P1 and P2 on line RS. We are to mark with 2 crosses on the line RS, and these are the positions of the pin that's at a suitable distance apart for this experiment. Okay, so next we need to draw this line. Okay, over here, we need to draw line RS. Okay, and this is 30 degrees to the normal. Okay, 30 degrees to the normal means from this normal, 30 degrees this way. Okay, the 30 degrees this way. All right, so what you do is same thing as per usual. Put your protractor over here. Okay, this is 90. Okay, 30 degrees from 90, right, is 60 degrees. Okay, let's remember, this is 0, this is 60, this is 90, so 60 degrees here. Okay, from AB. So once you do that, okay, now we can draw the line RS. Okay, which is from here to about here. Okay, this is your line RS. So far so good. Okay, RS is here, R and S over here. All right, and this is, please mark this properly as well, this is 30 degrees. Okay, 30 degrees. Now we are to place two pins P1 and P2 on the line. Okay, and we are to mark with two crosses on RS the positions of the pin, and they have to be a suitable distance apart. So basically, make sure, right, your pins of R and S are as far apart as possible to reduce the to reduce the errors to be read. Okay, so let's put one here, one X here, and let's put the second X somewhere here. Okay, right, let's label this P1 and let's label this P2. Okay, very good. So if you look at the less janky drawings, which has been done properly, it should look something like this. Okay, so far so good. All right, so this is also a 2-mark question, right? So how do you get your full 2 marks? Simply put, 1, right, your line over here, RS, is exactly 30 degrees away from an L, from this normal line. Once again, the invigilator, the marker of your paper, will put their projector on here. Okay, and they will check if this is 30 degrees away from the normal. Okay, next thing to take note, right, the second mark is if your P1 and P2 are about 5 centimeters apart. Okay, this will determine you another mark. All right, so just make sure your P1 and P2 are far enough. Okay, okay, so far so good, yeah? Okay, now let's move on to part C. Okay, the student looks from the position of the eye as shown in 3.1 to observe the images of P1 and P2 through side CD of the block. So he adjusts his line of sight until images of P1 and P2 appear exactly one behind another. Okay, so he places two pins, P3 and P4, on side CD of the block and his eyes, so that P3, P4, and the images of P1, P2 seen through the block is exactly one behind the other. And these positions of P3 and P4 are shown. So let's take a look at our diagram again. As you can see here, the dude put his eye here. Okay, the student put his eye here. P3 and P4 has been marked over for you. And from his angle, from their angle, right, P3 and P4, okay, and P1 and P2 looks as if they are in one nice straight line because of refraction. Okay, now let's read what they do here. Okay, we are to draw a line between the positions of P3 and P4 and continue until it meets the normal and L and label this point E. And we also are to label the other point in the line F. Okay, so we also are to measure the acute angle between EF and the normal. Okay, the acute angle is less than 90 degrees. Okay, so let's do this. the main point is to draw a nice long line between P3 and P4. So let's draw that. Okay, P4, let's put our on here. Okay, and let's draw. Like that. Okay. Okay. Now, next thing we need to do is, okay, we are to label this line E and F. So E is right here. Okay, and F is right here at the eye, right? Because it ends at the eye. Okay, and then we are to measure this acute angle using a protractor. An acute angle is an angle less than 90 degrees. Okay, so we can actually, from here, we put our protractor over here to measure this angle over here. Okay, so 0 is here. We are not sure what this is supposed to be. Let's take a look at our graph. Okay, sorry to forget to show this, but this is how it should look like. Okay, B over here, right? Okay, so over here, now you take out your protractor and measure this angle over here. Okay, the center of your protractor, please put it at point E and measure this angle. From my drawings over here, as you can see, this line, this angle, right, of LEF over here is 32 degrees from me for some reason. So let's write here 32 degrees. Okay, 32 degrees for this angle. Okay, all right. So we are also to write the angle over here. So 32 degrees. Okay, measure the angle and write it down here. Okay, okay, fantastic. All right, so hang on a second. So, all right, we are currently at question number 3 right now, by the way. Thank you for asking. So, Shamina, thanks for asking. We are at question 3 right now of paper 6-1 of winter 2025. Thank you for asking, and hope you are following up, of course. All right. Okay, let's move on. Okay, so we now have 32 degrees, and we need to find out, right, how are we going to get the full 2 marks of this? So let's check, right, how do you get your full 2 marks? Okay, and over here we are given that we are given 1 mark if we draw a nice straight line, okay, over here from connecting P3 and 4, and we are also given 1 more mark if the angle we measured is 32.0 plus or minus 1 degrees of error. Okay, so basically, once you have these 2 points done, you should have your full 2 marks. Okay, that's done. Okay, now let's move on to part D, the easy part. All right, so take 1 box to complete the sentence. To produce the most accurate ray trace, the student places the pins P1 and P2 exactly less than or more than 5 cm apart. Which one, right? So as we have mentioned before, okay, as long as the 2 pins are far apart as possible over here, right, it makes the reading a lot easier to read. So, of course, we want over here, we want the 2 pins P1 and P2 to be more than 5 cm apart. We take this. Taking this gets you your 1 mark. Okay? All clear? Okay. Right, so let's move on. D part 2 wants you to suggest 2 other techniques that a student can use to produce a very accurate ray trace. Okay, ray trace meaning how can you draw a good diagram like this, not how powerful your graphics card is. Okay, all right. So 2 techniques the student can use to produce an accurate ray trace. How do we do that? Number one, as you know, right, when you're drawing the diagram, you want to use nice, sharp, and thin pencils. So the lines are thin, okay? And also, number two, you want to make sure, right, that your pins that you're using, basically the pin P1, P2, P3, and P4 that you're using, right, is as thin as possible. So, right, there is less error on the readings, right? So let's write that down. These are the two answers you can use. So number one, okay, draw a thin line. Using a sharp pencil. Okay, okay, that's the first one. And secondly, we can use a thinner pin. More accurate results. All right. Last but not least, there's also a third answer. You don't have to write that down, but this is also accepted. The third answer is make sure the pin, right, as you pin it down, is pin. Oops, my goodness. Make sure your pin is pinned down vertically to your surface, so you can make sure it is nice and straight. Okay. Okay, so this is your full 2 marks. 2 valid points, 2 full marks. Okay, now part E. Okay, the student plans to investigate the relationship between angles I and angle theta, and the student should take more will take more sets of readings to test the relationship. So we are to list the values of angle I that the student can use. Okay, so what are the values of I that you want the student to do, right? So as you can see over here, right, we have the incident angle over here is 30, right? This is the first angle. So what other angles can we use over here to investigate this? These are suitable values, right? So you want to have the angles that are within here, within this 90 degrees. So it cannot be more than 90 degrees, okay? So let's just write down three, maybe, three angles, and the range between these angles is spread at least over 30 degrees. So let's say we can maybe use 10 degrees for the first angle. We can use 30 as the second one, as we have seen before already. We can also use 50 degrees, and we can use maybe 80 degrees as the third one. All right, so these are our three angles that we will be using. Okay, should be used. Okay. Okay, yeah, so we can use any of this. So how do we get the full 2 marks? Number one mark is awarded in the marking scheme if, right, if, okay, the angles over here is between 0 and 90, and the last mark is given if your range is spread over at least 30 degrees or more. So this is what we can do. Okay, this gets you a full 2 marks. All clear? Okay, and with that, we are done with question 3. Okay, so chat, any other questions you guys want to ask so far? Are there any questions from the chat? Okay, looking really good. All right, so far no questions, and looks like everybody is following pretty well. Fantastic. All right, now let's move on to our final question for today, which is question 4. This is the big one, okay? This is the really, really big, the long question that, makes why, questions like this are the most difficult, right? You are to plan your own experiment. Okay, let's move on. Okay, let me just zoom out just a little bit. Okay, All right, let's move on. So question 4, a student is investigating electrical heaters that are used in a school lab to heat beakers of water, right? And the heaters are all 12 volts with the same power rating. And the student thinks some heaters are more efficient than other heaters. Okay, same power rating, more efficient than other heaters. So we are to plan an experiment to compare how quickly the heaters increase the temperature of water to the boiling point. And these apparatus are given to the students. So we're given 5 different heaters, okay? We are given some beakers, a supply of water, and a 12-volt water power supply with the suitable leads. And of course, some other apparatus normally available, such as thermometers and so on and so forth, can also be used. So in the plan that we are to write, we are to list any additional apparatus that are required. Okay, that's number 1. Number 2, we are to explain briefly how you do the investigation, including the measurements you take. So number 2 is to describe how to do this experiment and what are the measurements you will be taking. Number 3, you are to state which are the key variables to be kept constant. Okay, so we are looking for the independent variables here. And number 4, we are to draw suitable tables with column headings to show how to display your readings. And you are not required to put in any readings on the table. And last but not least, you are to explain how do you draw a conclusion using these results. All right, so most people, when they look through these questions, it is looking a little bit intimidating. And this whole question is 7 marks. They give 7 marks to this, all right? Okay, so let's go back to the top of the question. So we all know that the student wants to find out, right, which heater is more efficient than others, right? And we all do know that the heaters all have 12 volts and have the same power rating. Okay, so we can plan this. We can plan using how these heaters heat the water to boiling point, and we can basically it's already been said here. We have to find how quickly the heaters increase the temperature of water to boiling point. So regarding the temperature of water that was given to you, right, in a tap, right, we do know that we have the water in room temperature, which is about 25 degrees Celsius. That's room temperature. But we have no idea if this is going to be constant for everything. So first thing first, we need a few more equipment, right? We need a thermometer. Okay, so when you are heating up your water, right, you need a thermometer to measure the temperature of water initially and when it actually hits 100 degrees Celsius. So yes, although water boils 100 degrees Celsius, right, we don't know when you want to start and stop the stopwatch, okay, when you start this experiment. Number 2, you will need a stopwatch. Okay, simply because we need to time how quickly the heaters increase the temperature of water to boiling point. So these are the 2 extra equipment you need in your experiment. Okay, so we need a stopwatch. Okay, number 2, how are you going to do this experiment? Okay, so first things first, right, you need to measure the initial temperature of water, right? Okay, and then number 2, you put the heater in, turn on the heater, okay, and then start the stopwatch at the same time. Turn on and start the stopwatch at the same time, okay? That's the second one you'll do. Number 3, you wait for the thermometer to hit 100 degrees Celsius, okay? And then when it hits 100 degrees Celsius, stop the timer, okay? Then once that is done, we can probably retry this. You can redo this experiment a few times to have an average answer. And that's how you get the reading value for one particular heater. Okay. And number 4, we'll draw a table. Let's do that later. And 5, explain how you use the results to reach a conclusion. So essentially what we do know is if the heater heats the water quicker to 100 degrees Celsius, right, that heater is more efficient because, right, less energy is lost to surroundings and more heat is used to boil the water. Okay, so the heater that actually uses the heater that boils the water the fastest is the most efficient. Right, so with all that said and done, let's write down our answer. Okay, right, so instead of me writing down the answer, let me just type it out. It's a lot easier. So let's write it down. Okay, for this experiment, the 2 additional apparatus needed are a stopwatch to measure the time taken to boil the water and a thermometer to measure the initial and final temperatures of the water. Okay? Right, so this is our first part of the answer. Okay? First part done. Okay? First answer done. So we have 2 equipment we need. Okay? This is the first part done, which is the additional apparatus required. Now, let's move on to the second part we need to write down, right? It is explain briefly how you do the investigation, including the measurements you will need to take. All right. So first, let's write down how are we going to do this question, right? Firstly, we measure the temperature of the water to ensure that the initial temperature of the water is constant for all experiments. Okay, so we make sure that the initial temperature of water, which is also one of the variables, right, is constant. So the first thing we need to be constant is the initial temperature of water, right? Now let's move on to the next thing. Okay, next we pour 250 ml of water into a beaker. This is to be constant for all subsequent experiments. Okay, this is our next line. We need to make sure the amount of water is constant for all experiments. Okay, hold on a second. All right, so now that is done, let's move on. All right, 1 second. Yeah, all right, let's move on to the next part, okay, which is the okay, now this is made constant. We want all subsequent experiments. Okay, I almost forgot to write one more thing. All right, then insert a thermometer into the beaker to monitor the temperature of the water. Right? Great. So now that's done. Okay, let's move on to our next part. Okay, now next we insert the first water heater which we call heater 1, into the beaker. Okay, we plug it into the mains, the 12-volt mains supply, sorry, not mains, power supply, and turn it on. So as we said before, once you put in the power supply, we turn it on and start the stopwatch immediately. Okay, we start the stopwatch when the heater is turned on. Okay, right, pretty straightforward so far, yeah? Okay, very good. Now next, okay, so once you turn on the heater, the water will rise in temperature until it hits 100 degrees, where that is the boiling point of water. So when the water reaches 100 degrees Celsius, okay, 1 second, need to find the symbol for degrees Celsius. There we go. As read by the thermometer. Stop the stopwatch and record the time taken for the heater to the water to reach boiling point. Okay, so this is our next step. Okay, good. Now that once that's done, okay, we also can, this is optional, but I think it's better to do it, repeat the same experiment for heater 1, heater 1 2 more times to obtain a total of 3 readings for, okay, an average reading. Okay, so with that, right, we should be able to do this. All right. Okay, and then, okay, then once that is done, once the first heater has been used 3 times, right, we can repeat the same procedure for heaters 2, 3, and 4, and so on. Thus, for all the other heaters, okay, okay, including the 3 readings per heater and taking the average. Okay, so that's done. Now, finally, we can say, right, when all heaters are tested, okay, heater that is, that boils water the fastest can be determined as the most efficient heater. Okay, the heats water to boiling point the fastest and is determined as the most efficient heater. All right, so there we go. As we have stated before, right, we must show what are the apparatus required, which is the thermometer and the stopwatch. Okay, we need to explain how we do the investigation, which is all written down here. We need to state the key variables to be kept constant. Basically, we have stated that the volume of water is constant, which is over here, and also the initial temperature of water should also be constant. All right, and then using a suitable table with column headings, we will do that later. And last but not least, we are to explain how we use the results to reach a conclusion. So as we have said before, the heater that heats the water to boiling point the fastest is the most efficient heater. Right, now I would draw the graph that we are going to show. Okay, as we have seen before, right, we have a certain number of heaters over here. Of course, once again, please pardon my horrible drawings. Okay, please do this with a ruler. Okay, don't be like me. All right, so over here we have the heater number. Okay, we also have the first time reading in seconds. Okay, the second time reading also in seconds. All right, the third time reading also in seconds. And then last but not least, you have the average time, which also can be seconds. Okay, of course we have heater number 1, 2, 3, 4, 5, and so on. Okay, so as seen here, we have the 3 timings here. We will sum these 3 up, divide by 3 to get the average time. Okay, this is our this will be our table required for this question. Okay, so how are we going to achieve the full 7 marks for this question? What is Cambridge looking for? All right. Most importantly, please don't write a grandmother story. We have to get straight to the point. We have to be very clear and concise. Okay. So in the marking scheme for this question, so 1 mark is awarded for a suitable timer and a thermometer. Over here, we have a thermometer and a stopwatch. We should also write digital stopwatch, okay? If you want to be very, very clear about this. So this gives you 1 mark, all right? So 1 mark awarded if you mention that you are going to find the time taken to heat water to the boiling point measured. So yes, we have written over here to measure the time taken for water to reach boiling point. So this is another mark over here. Okay, so 1 more mark should be given if you do the same for the other heaters, which is also written over here. Okay, right. Now, next thing we need to know is 2 marks are awarded for 2 variables that are kept constant. So the 2 variables we have kept constant are the initial temperature, that's 1 mark, and we also have a amount of water, which is constant, 250 mils of water. This is the second constant. So these 2 has to be kept constant, okay? Right, so it can also be the mass of water, same amount of water, same mass of water, same volume of water, okay? That's 2 marks. And next, right, we are to, if the next mark, right, is given if you give a table over here with clear columns for heater and time with units. So heater is over here, as we see here, and time is given in seconds. So as long as you do this properly, with with properly drawn tables and a properly drawn table with a ruler, unlike mine over here, you should be able to get your 1 mark. Okay, And last but not least, you are to get 1 mark to draw a proper conclusion. So the conclusion over here we have is if when the waters are heated, right, the heater that heats water to the boiling point the fastest is the most efficient heater. This is a correct conclusion. With that, you get 1, 2, 3, 4, 5, 6, 7 marks in total. And that is how you score full marks for a question 4. Okay? All right. So now that we are done with question 4, do you have any other questions in chat? So if you have any questions for our teachers over here, please comment in chat, please ask in chat. We have about 10 questions that are free to ask before we end today's video. All right, so please don't feel shy about this. Chat, please go ahead and ask away. For Naransa, do we have any questions from the chat? Okay. As I said here, please draw a table with a ruler. Please don't draw it freehand like this. This is not neat at all right? So please make sure to draw your table with a ruler and make sure it's neat, nice and neat, okay? Yeah. With that done, and okay, Naran sir, there's no questions, right? All right, thank you so much. All right, then with that said and done, all right, before we finish, let's go back to this. All right, so now we are done with paper 6-1 of IGCSE Physics, winter 2025. So now we are done. Thank you guys so much for being a fantastic audience. Now, do please go to homeschool.asia and go to ciepapers.com to use our past year papers and also to engage in the best ever homeschooling platform you will ever see. All right. With that done, thank you so much, and we'll see you next time. Bye bye.